Good day and welcome to today's class where we're discussing something new, that is matrices. Okay, so what is a matrix? A matrix is an ordered set of numbers listed in a rectangle or in a curved bracket. Now, when we say matrix, by definition, we say it's an array of numeric or algebraic quantities which are subject to mathematical operations. Like we carry operations on numbers, we can also carry out operations on matrices. Now, matrices can be defined in terms of their dimensions, that is the number of rows and columns we have. For instance, if a matrix have 3 rows and 4 columns, we can say, okay, this matrix is a 3 by 4 matrix. Do you understand? So the number of rows and columns are used to define or tell us the kind of matrix or naming the matrix. Okay, so let us take a look at a matrix with 4 rows and 3 columns. Of course, we denote this as what, a 4 by 3 matrix. Now this times, the middle is not times, it's called by, a 4 by 3 matrix. So do you understand what I'm saying now? And for instance, if we call this matrix A, this is matrix A, you can see A there. So what is the dimension of this matrix? We say how many rows does it have? That's 1, 2, 3, 4. If I draw a line from A11 to A13, that is a row. On that line from A21 to A23, on that row. So the row goes from the left to the right. So we have 4 rows. Now how many columns do we have for this matrix? We have 3 columns. If I draw a line from A11 to A41, that will give me a column. And on that line from A12 to A42 on that column. So we have 3 columns. Here we have 1, 2, 3, and rows we have 1, 2, 3, 4. So this matrix is a what? Is a 4 by 3 matrix. I believe that is clear. Okay, now what do we call individual elements of a matrix? We call it cell. I said each individual item in the matrix is called a cell and can be denoted by the particular row and column it resides in. For instance, in matrix A, element A32 can be found where the third row and the second column intersect. For instance, if we want to find the location where an item in the matrix is or is residing, for instance, if we have a number here now and that number is at 833, what do you mean? It means, look at 83 for instance. Why do you name it 33? Because 83 occupies the third row, 1, 2, 3 row, and the third column. 832 occupies the third row and second column. So 3, 2, the 3 means row and 2 columns. So row comes before column in matrix. Do you understand? Okay, where is this item located? This A12. Can you see that? Why? Because it occupies the first row and second column. Alright, so let's continue. Determinants. Okay, matrices and determinants were discovered and developed in the 18th and 19th centuries. Initially, their development dealt with transformation of geometric objects in solution of systems of linear equations. Historically, the early emphasis was on determinant, not the matrix. In modern treatments of linear algebra, matrices are considered first. We will not speculate much on this issue. Matrices provide a theoretically and practically useful way of approaching many types of problems, including, okay, for instance, we have types of matrices. We have what they call the symmetric matrix, we have the diagonal matrix, we have we have the triangular matrix. So we can divide into upper or lower triangular matrix. We have the zero matrix and we have the identity matrix. We also have other types like the skew symmetric, we have the singular matrix, we have etc. You understand, the square matrix and the likes. Alright, so we will talk more on that later. Okay. Alright, now I told you that where an item is found is where the row intersects the column. For instance, A32 is found where the third row intersects the second column. Okay, so if this matrix is called matrix A, this matrix has 3 rows and 4 columns. We say it is a 3 by 4 matrix. We denote the element in second row and fourth column with what? A24. Okay, now what is A24? When you see A24, it means in this question, what's A24? the element in the what? In the second row before column, and fourth column. And what is that element? Second row, this is first row, second row, and fourth column. 1 2 3 4. So that is what, if we dot the 2, we have 9. 9 is at 8 3 2, 8 2 4. Do you understand? 9 at 8 2 4. Okay, so what is a square matrix? When we say a matrix is a square matrix, what do you mean? Of course, you can have matrices like A33, A22, A44, A66, A55, etc. Now, when the number of row equals number of columns in a matrix, such matrix is called a square matrix. Alright, so if a matrix A has n rows and n columns, can you see that? N rows and n columns, then we say it's a square matrix. In a square matrix, the elements A, I, J, this should be I, J, with I rows, I can be 1 2 3 etc., are called diagonal matrix. Now, there is no difference between a 1 by 1 matrix and an ordinary number. Okay, I will explain that later. When we say a 1 by 1 matrix, what do we mean? A matrix with a single row and a single column. For instance, if you have a matrix and it's only having 2 as its element, now that could be a matrix. There's no difference between such matrix and an ordinary number. Do you understand? The number we count before, like 1 2 3, those numbers are matrices with one, now defined as 1 by 1. Do you understand? Okay, now let's look at this matrix. I want to talk about diagonal matrix. I've talked about square matrix, a matrix that has the same number of rows and columns, like A33, A44, etc. Alright, for diagonal matrix, a matrix that has elements only in the major diagonal. And we say major diagonal, if you draw a line from 7 to 6, can you see? That is the major diagonal. You draw it towards the right. While we have the minor diagonal as drawing a line from 0 here to 5, to 0 through 5 and ending at 0 here. That will give us the minor diagonal. While this is major diagonal, draw a line from 7 through 5 touching 6, major diagonal. Now you can see in this matrix we only have elements in the major diagonal, hence we call it a diagonal matrix. A diagonal matrix is a square matrix with all the non-diagonal elements. This is THED, sorry, with all the non-diagonal elements as just 0. The diagonal matrix is completely defined by the diagonal elements. So the elements in the diagonal matrix, must always be found in the main diagonal. Do you understand? Okay, now let's move forward to row matrix. What is a row matrix? This is an example of a row matrix here. This 2 5 7, 2 5 7. 2 5 minus 15. What do we call that? Why is it a row matrix? Because a matrix is a matrix that has a single row. Can you see? Any matrix with a single row, with any number of columns but a single row, is called a row matrix. The word A means one row matrix. So a matrix with one row is called a row matrix. We can also have a column matrix. A matrix with one column is called a column matrix. Sorry, this is actually joined together. So a column matrix, a matrix with only one column. You can have any number of rows, but then the column must be single. Okay, so let's talk about similar matrix. When I say a matrix is similar to another matrix, what are we saying? It means every element in matrix A is equal to the elements in matrix B. So if we have the same elements in A, in all A cells, and we have such elements in also B cells, and they are of the same in everything, then we call them similar matrices. Okay, look at this. Okay, but this one, matrix of same kind, matrix A and B are of the same kind if and only if A has many rows as B and has as many columns as B. Look at this. If you have 7 1 2 0 5 6 and this, and we have this, but these are not similar matrices. Actually, these are matrices of same kind but not similar matrices. When you say matrices are similar, the elements are the same, also the same, and such matrices can be added. But this kind of matrix, we call them matrices of same kind. Why? Because the number of rows and column are the same. So this is a what one. How many rows we have here? 1, 2, 3. How many columns? 1, 2, 3. So this is a 3 by 3 matrix. This also is 3 by 3 matrix. So when the number of rows and column are the same, we call them matrices of the same kind. But when we call them similar matrix, it means both the elements and the order of the matrix are the same. When we say order, for instance, the order of this is what? 3 by 3. It's a 3 by 3 matrix. Was that 3 rows and 3 columns? But when you say the elements are the same, it means this: if here is 7, here is 7. If here is 1, here is 1. If here is 2, here is 2. So this is not, these two are not similar matrices, but they are matrices of same kind. Do you understand? Alright, so let's talk about the transpose of a matrix. When we say transpose, to transpose a matrix means making all the rows the column and making the columns the rows. For instance, look at this matrix here. We have matrix 7, 1, 0, 5, 3, 4. What kind of matrix is this? What order is this matrix? It is a what? How many rows? 3, column 2. It's a 3 by 2 matrix. Now when we start making each matrix, we start making, each row a column. So pick 7 and 1, which is the first row, then turn it like you're turning it around. It becomes 7, 1. It becomes the column of this one. So 7, 1 is arranged as 7, 1, 0, 5 arranged as 0, 5, and 3, 4 arranged as 3, 4. So we have that as a transpose. So we are trying to transpose the matrix. Do you understand? Alright, so we also have what they call the zero matrix. Zero matrix. When all elements of a matrix A are all 0, we call a zero matrix. Do you understand? Now we write shortly 0 for a zero matrix. For instance, if you have a matrix of n by n order and everything inside the matrix is 0, so we call that a zero matrix. There's no element aside from 0. Alright, so let's talk about an identity matrix. An identity matrix is a matrix that has 1 in its major diagonal and other elements in the matrix are 0 in value. They have 0 as the value. The non-diagonal elements are 0, while the diagonal elements are what? Just 1. We call it identity matrix, and we use the letter I to represent the identity matrix. So let's talk about the scalar matrix. Scalar matrix is a diagonal matrix whose diagonal elements all contain the same scalar value. For instance, look at this. This is scalar matrix. Why? Because in the main diagonal we have 7, 7, 7. So because the same element 7 are there and other non-diagonal element are 0, we call it a scalar matrix. Do you understand? So we also have what they call the opposite matrix of a matrix. If we change the sign of all the elements of a matrix A, we have the opposite matrix minus A. If A prime is the opposite of A, then Aij equals to minus Aij for all I and j. What do you mean? For instance, if we have a matrix whereby all the elements are positive, the opposite matrix will be what? Same matrix having all the elements as what? The same element there, but they obtain a different sign, which is 0, which is negative, minus. You understand? And if you have a mixture of plus and minus numbers in a matrix A, then the opposite matrix B will be a matrix containing the same element, but each number will have an opposite sign. Numbers that were plus before become minus, and numbers that were minus before become plus. Do you understand? So that is what they call an opposite matrix. We have what they call a symmetric matrix. A square matrix is called symmetric if it is equal to its transpose. For instance, when you transpose this matrix now, you will get the same thing. I told you that if you transpose this, we have 715 for the column. Can you see 130 and 507, which is what is here as well? Can you see that 715? If you check, we have 715. 130, you have 130. We have 507. We have 507. So a matrix such that when transposed still gives the same initial matrix is called a symmetric matrix. And we have what they call the skew symmetric matrix. A skew symmetric matrix is called skew symmetric if it is equal to the opposite of its transpose. It means after transposing the matrix, then those numbers we have the same number, but then opposites. Those that were plus before become minus, and vice versa. Alright, so let's quickly do operations on matrices. We'll talk about addition and subtraction. Today we're talking about only addition. Now, when do we add a matrix together? only when these matrices are similar. I told you what they call similar before. When we have the elements, okay, not similar actually, when they are of the same type, sorry, the same kind. For instance, you can only add a 2 by 3 matrices to a 2 by 3 matrix.